Today we are doing 7.2 extra practice, just to practice some more on those graphs and to try to, I'm going to emphasize what I want on each different type. And so we have this rational graph in example 1, g of x is negative 4 over x, and it says to compare with f of x. And so on that one, we have this g of x, and you need to think of it as a negative 4 times 1 over x. And so you have 1 over x is f of x, and when you take f of x times a negative 4, that's a reflection in the x-axis because of the negation. And the times 4 is a vertical stretch by 4. So that is what you need to do in terms of the comparison. So g is a reflection in the x-axis and a vertical stretch by 4 of the function f. That's what it is. G is a reflection in the x-axis and a vertical stretch by 4 of f. That's what is needed for that description. Now to graph this, I want to think of it as y is equal to negative 4 over x. And if I multiply both sides by x, I get x times y is a negative 4. If I multiply both sides by x, I get x times y equals negative 4. And so the last lesson, how I talked about that is I'm looking for pairs of numbers that multiply to be negative 4. And so I'm going to create a table of values and find pairs of numbers that multiply to be that negative 4. And I want you to find the vertices. And vertices for y equals a over x, and this is for when a is positive, are going to be the square root of a, square root of a, and the negative square root of a, negative square root of a. If a is negative, then you're going to have root a and a negative root a, or a negative root a and a positive root a. You need one positive, one negative, so that the product's negative. So that's going to be your vertices. And so for this problem, you've got 4 in the numerator. Well, the square root of 4 is a nice, neat, clean 2, so you need a 2 and a negative 2, and you need a negative 2 and a positive 2, because you need them to multiply to be that negative number. And I left a little space in between. I want at least 3 points on each branch of the hyperbola. And so pairs of numbers to be negative 4, I would use 1 and negative 4, and I would use 4 and negative 1. And then where the x's are positive, just make the x's negative and the y positive. And those would be the ordered pairs on the other branch. When it is of this form right here, 1 over x or any value over x, the horizontal and vertical asymptotes are the x and y axes, because there's been no shift left or right or up or down. And so my vertical asymptote is going to be x equals 0, and my horizontal asymptote is going to be y equals 0. And so I can put those in. And so I've got those graphed. And then I can plot these ordered pairs. Go to the right 1 and down 4. Go to the right 2, down 2. Go to the right 4 and down 1. And those are 3 points on one branch. So you need to draw the branch. And don't forget the arrows on the end of the branches. And at the ends, you just want to try to have them run parallel to those asymptotes. For the other branch, negative 1, 4, negative 2, 2, and negative 4, 1. So I want, again, 3 points on each branch. And this is a branch of that hyperbola. Don't forget the arrows on the ends. And typically, I want the vertical and horizontal asymptotes. I want the vertices. And I want domain and range. And in this one, the domain and range are the same because they're both skipping over 0. And that's how we use interval notation to skip a single value. So we have the comparison, which was asked for. And then the rest of this, I'm going to want, the textbook isn't going to have those in their answer, but you should have those. And that's where part of the issue and why we have to repeat this the second day is the textbook answers don't have everything that I'm asking for. But you should just be in the habit of including them. Any questions? Yes.
We're not going to get marked off if we didn't do all of that.
Not on last night's. No. So that's why, but tonight so in terms of homework, I'm going to come around and check yesterday's or Friday's. And I'm just going to kind of look that you did a good job of completing it all. But then tomorrow I'll probably collect your homework and look at it a little more intently because today I'm being more specific about what you need. All right, so thanks for the question. All right, example 2. This has a translation. When it's in this form, you need 2 tables of values, one for the parent function, and the parent function on this is y is equal to a negative 8 over x. It's pairs of numbers that multiply to be 8 are ordered pairs on the parent function. And from the parent function, you're going to be going left 2 and up 1. Because of that x plus 2 in the denominator, you go left 2. And the minus 1 on the outside, you go down 1. So we're going to have a vertical asymptote. It's been shifted to the left 2. And, oops, I said up 1. I hope you're wondering. It's not up 1. It's a minus 1. It is down 1. It's not opposite side. The x plus 2 makes you go left 2. The minus 1 makes you go down 1. Sorry about that. And so you're going to have a horizontal asymptote at y equals negative 1. So vertical asymptote is x equals negative 2, and your horizontal asymptote is y equals negative 1. So you're going to need all of that in there. And first of all, give me tables of values of numbers that multiply to be that negative 8. And for the vertices, they are going to be the square root of 8 and a negative square root of 8, a negative square root of 8, and a positive square root of 8. And when you actually list the vertices after they've been translated, you need to simplify those to 2 root 2. We're not going to leave it square root of 8. That should be an obvious, wait a minute, that simplifies to 2 root 2. It's perfect square of 4 in there. But for plotting purposes, it's better to just think of it as a square root of 8 because you're going to have to approximate it. So we'll just leave it that for there. And after that, you need numbers that multiply to be negative 8, 2 numbers. And you could use 1 and negative 8. You can use 2 and negative 4. It's really a choice. And sometimes if you plot them and it just doesn't give you enough of the curve of a branch, then, try some other numbers further out. For this one, I chose 2 and negative 4 and 4 and negative 2. And then for the other branch, it'll be the x that's negative and the y that's positive. Now these are points on the parent function. I want to get the points after the translation. And so that's getting points on that final graph of negative 8 over x plus 2 minus 1. And what I want to see is when you go left 2, you should know you're subtracting 2 from all your x values. So just go down the list of x values and subtract 2. You get 0, you get root 8 minus 2, you get 2, you get a negative 4 minus root 8 minus 2, and you get a negative 6. Just drop all of those x values down by 2 because you're going left 2. Subtract 2 from x. And then you need to go down 1 for y, and so subtract 1 from y. And these are your ordered pairs for where we're going to plot. And before I go to plotting those, let's go ahead, and domain is everything except for -2. And range is everything except for -1. Okay, and then for the vertices, I'm actually going to put those down here just a little further. The exact values are negative, or is square root of 8, which we're going to write 2, not negative, 2 root 2 minus 2, and a -2 root 2 minus 1. And your second vertice is a -2 root 2 minus 2, and 2 root 2 minus 1. So I'm just taking these ordered pairs, but I'm writing the square root of 8 as 2 root 2. And those two sets of ordered pairs, and just swapping out root 8 with 2 root 2. Those are the exact values. Now, you need some kind of approximation here. And so I'm going to go square root of 8. Well, it's very close to the square root of 9. Square root of 9 is 3. And without a calculator, just approximate it. So if you use 2.7, 2.8, 2.9, any of those, that's fine by me. I'm going to use 2.8. So I'm thinking of this as 2.8 minus 2, a -2.8 minus 1, a -2.8 minus 2, and 2.8 minus 1 to approximate those so I can get them graphed. And so I just approximate them so that I can graph them. In terms of my answers for, labeling the vertices, these are my answers, the exact values. So now go through, and I'm going to start by plotting the two vertices. Because A is negative, I expect a branch here, and I expect a branch here, because A is negative. And so we have 0.8 and down 3.8. So somewhere there is my first vertice. My second vertice, go to the left 4.8 and up 1.8. So about there. And then continue with the other 2 points on each branch. So we have 0, -5, and 2, -3. 0, -5, and 2, -3. And we have the branches, the asymptotes, so we can kind of just draw it. Don't forget the arrows. And there's one branch. We have the 3 points, which is my requirement. And then we have -4, 3, and -6, 1. So -4 and then 3. And -6, 1. So there's my 3 points on the other branch. And there we've got the hyperbola graphed. And so far we have the translation, left 2, down 1, vertical, horizontal, domain, range, the vertices listed. I think that's everything that was asked for. Any questions on that? So the big miss on people's homework from day 1 was when it's in this form, there were not two tables. You need the two tables on tonight's homework due tomorrow, when it's in this form, where it's been translated. All right, so then let's go ahead to the next page. And this is where things, switch up. This is in a different form. This is a linear over a linear. And so when it changes form, how we find vertical and horizontal asymptotes change. And what we're not going to be finding a parent function and then translating the points. We are going to do a table of values and actually substitute x values into the function to get the y values to plot the points. So how you approach graphing this changes with the different form, trying to build flexibility. In chapter 2, you had 3 different forms of the quadratic equation. You had standard form, you had vertex form, you had intercept form, and when you had each of those forms, how you find the key elements changed up. Well, same thing here. So on Friday, I said to find the vertical asymptote when it's in this form, you set the denominator equal to 0, you solve for x, and you get this negative d over c. That is how you find your vertical asymptote. Your vertical asymptote are excluded values, and when you have a variable in the denominator, you can't let the denominator be 0. If you go down to example 3, the vertical asymptote, I need to figure out what makes the denominator equal to 0. And so the vertical asymptote is x equals 2. I can't use 2, it makes the denominator 0. So that means I have a vertical asymptote at x equals 2. For the horizontal asymptote, it is the ratio of those leading coefficients. It is the ratio of A to C. It is that ratio of A to C. So it is y equals A over C. That is how you find your horizontal asymptote. So in example 3, the A value is negative 4. The C value is 1. And so it is a negative 4 over 1, and so my horizontal asymptote is y equals negative 4. And so that is how we're going to find our vertical and horizontal asymptote. You need to be a little bit careful because we have a lot of examples where the denominator, the coefficient there is 1, and some people make the conjecture, the horizontal asymptote is y equals that value. Well, not always. Just for example, what if I had f of x equals 4x plus 3 over 7x minus 1? The horizontal asymptote would be y equals 4/7. It is the ratio of those leading coefficients, so just be careful on that. So anyways, on the graph, we could go ahead down to negative 4. Oops. And put in that horizontal asymptote. And now I'm going to have you do a table of values, and you look at where the asymptote is. That x value is 2. You need to pick 3 x values to the right, so I'm going to use 3, 4, and 5. Now, those might not always get you the curve that you're looking for that branch. You might want to do 4, 6, and 8. But I need 3 values to the right of the asymptote, and I need 3 x values to the left, so negative 1, 0, and negative 1. Or you could do 0, negative 2. You just need 3. Pick 3 x's to the right, 3 x's to the left, and do a table of values. And so to the right, I've got 3, 4, and 5. And you are just plugging them in. Negative 4 times 3 plus 13 over 3 minus 2. You get a negative 12 plus 13 is 1 over 1. When you plug in 3, you get 1. When you plug in 4, you get negative 4 times 4 plus 13 over 4 minus 2. Negative 16 and 13 is a negative 3 over 2. And it is that. It's a negative 1.5. Plug in 5, negative 4 times 5 plus 13, all over 5 minus 2. Negative 2013 is a negative 7 thirds, which is a negative 2 and 1/3 in terms of plotting. And then you need to evaluate for 3 values to the left. I used negative 1, 0, and 1. So 3, 1, 0, negative 1, or negative 1, 0, 1, whichever you want to put them in. And you evaluate. Now, I'm just going to go ahead and give you the values. I'm not going to take time to, crunch them all out. I would expect that you could do it. And when you put in 0, you get that negative 13 halves, which is a negative 6.5. And then when you plug in 1, you get a negative 9. So again, you're plugging them in and evaluating. And now plot them. If you go to the right 3, you're up at 1. If you go to the right 4, you're down 1.5. And if you go down right, or 5, you're down 2 and 1/3. And so I've got 3 points. I've got asymptotes that I can follow. Or attempt to. And don't forget the arrows. And then at negative 1, I'm down 5 and 2/3. At 0, I'm down 6.5. That's your y-intercept. And at 1, I'm down at negative 9. And so draw that branch. And so you're not asked for vertices in this form because it isn't where we have the parent function. You need the table of values. It asks for the vertical and horizontal, but what we don't have is domain and range. Domain, you're skipping over 2. And the range, we are skipping over negative 4. So, different structure, how you go about finding some things and graphing it is different. And then in example 4, we're making the connection that if it's in that form of a linear over linear, it can be changed into the form where we can approach it as a transformation. And we do that through long division. And so we're going to take, oh, by the way, this isn't right on your paper. I don't know what happened in terms of when I copied it off, but if we use the one that's on your paper, we get an A value of like 31 or negative 31 or something. And it's like, yeah, no, we're not going to do products of numbers that multiply to be 31. It's just more awkward than what's needed. So anyways, please change it to 4x plus 7 over x plus 1. And so we are going to take x plus 1 and divide it into the 4x plus 7. And then I need this x to match this 4x. That's how you make your decision. I need to multiply by 4. So we're going to put a 4 up here, multiply by 4. And then subtract, and we get a remainder of 3. And so that means g of x is you take the remainder and write it over the divisor, and then it's plus the quotient of 4. So we write it in a different order than what we do when we're actually in longhand division. Excuse me. And now we're going to apply this like we did example 2 on the front. We are going to apply it as a transformation, and the parent function for this is going to be y equals 3 over x. And for that you're going left 1 and up 4. So that means that my vertical asymptote is going to be x equals -1, and my horizontal asymptote is going to be at y equals 4. So there are my vertical and horizontal asymptotes. And so I'm looking for pairs of numbers that multiply to be 3. And the vertices are going to be square root of 3, square root of 3, negative square root of 3, negative square root of 3. Because the a value is 3. And pairs of numbers that multiply to be 3, I'm going to use 1 and 3. We could use 1/2 and 6. They're choices. And so I've got 1 and 3 or 3 and 1. And then where they're both negative. I'm going to leave room for, never mind, I went in the wrong direction. So at this point, we can go ahead and translate them. So we can get the points that are actually on G. And by subtracting 1 from all the x's, you're going left 1. So subtract 1 from all the x values. And you're going up 4, so add 4 to all the y values. And those are the points that we're going to need to plot. Before I go to getting the vertices and getting their approximation, I'm just going to go ahead and quickly put in domain is -∞ to -1. Union -1 to infinity. You have to skip over that -1. And for the range, you're going to be skipping over 4. So -∞ to 4 union 4 to infinity. And then we have vertices. And they are root 3 -1, comma, root 3 plus 4. And then minus root 3 -1. And minus root 3 plus 4. It's helpful to know that the square root of 3 is about 1.7. Just like the square root of 2 is about 1.4, those are helpful things to just know. So when I'm going to go to plot these, I'm going to think this is 1.7 minus 1, 1.7 plus 4. So that vertice 0.7, comma 5.7. And the second vertice is about -2.7 and 2.3. So you're just, again, you know, thinking if it's on a no calculator part, approximate the roots, and you're going to have to do some addition, subtraction of some things with a decimal or so. And so part of your answer is the transformation. It's getting g of x in that form. And then these are all typical things that I'm going to want to know when you go to graph this. And then we need to plot it. So my vertices are at 0.7, 5.7. So there's that one. And negative 2.7 up 2.3. About right there. So those are my two vertices. And I need to go back and pick up the 0, 7 and the 2, 5 for the one branch. So 0, 7, and 2, 5. And there I've got 3 points. Again, don't forget the arrows on your branches. And then go back and we need negative 2, 1, and negative 4, 3. So negative 2, 1, and negative 4, 3. And there's 3 points on the other branch. So again, it's just reinforcing what we did on Friday, being more specific about what I want to see. And so make sure you include that tonight, even though the textbook doesn't have that on everything. That's it.